Okay, I think we can get started now. So I am Stephen Graves, Special Projects Editor at Decrypt. Welcome to this webinar in conjunction with QuickNode on streamlining blockchain, demystifying real-time insights and simplifying data management. I'm joined by an excellent panel of speakers. So if you'd like to just briefly introduce yourselves, guys.
Thank you, Stephen. My name is Nick. I'm a director of product at QuickNode. We've been working on a few data and ETL related products, and I'm really excited to have this conversation with you guys. I'll pass it over to Carl, the head of DevRel at QuickNode.
Hey everybody, my name is Carl DiClementi. I'm the head of developer relations at QuickNode. I've been working in the blockchain space for about 7 years now with a lot of experience on the data side, and really excited to talk about where the industry is going and how we're helping solve some problems. I'll pass it over to Andrew.
Hey everyone, I'm the Headmaster over at Dune. I'm here to basically help you understand and help your teams work with crypto data across the pipeline. So that's raw, decoded, transformed. Basically think of Dune as your all-in-one data platform. So happy to be here.
Hi everyone, I'm Antonio. I work for FluidKey. I'm a CTO there, and with FluidKey, we want to bring a default privacy on chain by unlinking the fact that a user identity is an address, but user identity is something different from an address. And this brings a lot of tech challenges, and I'm here for this.
Great stuff, guys. Well, I suppose the obvious place to kick off with is what's the current state of blockchain data management? What sort of challenges are users sort of most commonly facing in the space? I don't know who'd like to pick up with that one first.
I'd like to pick up this one. Since we're sitting on top of all the blockchain clients and we keep on adding chains, we've noticed a very obvious and clear trend. Just like peeling the onions of all the challenges, we're starting with the most basic one. The explosive growth of blockchain data. We saw more chains on the market. We saw an explosive growth of use cases, which brings me to a question that I want to engage our audience today with. We know that lots of people are joining us to hear about the data challenges, but they are very specific to use cases. And I'd like to run a poll with our audience. What are the use cases that brings the more challenges to them personally? What are the ones that matter most to them? Let's launch a quick poll to see the use cases for enhanced blockchain data they are most eager to learn about today. And I'll pass it over to Carl. We had a chat today in the morning about the raw number of chains that have meaningful activity. Can you comment on that? What are the chains you see the most traction on?
Yeah, I think it's been really exciting to see the explosion of chains recently. You know, I remember back in 2017 when a lot of new, chains were launching and whatnot, but it's still nothing compared to today. One of the chains that just launched recently on QuickNode is Blast, and the really adoption on that chain has been incredible. Before that, Base was a great example, and a lot of these new L2s that are coming out. And this is really thanks to the tooling that, ecosystems like Optimism, Arbitrum, ZK, Sync, etc. are all providing to make it as easy as possible for people to launch additional chains. Back in the day, we used to talk about how it would be really difficult for a real world solution to come onto the blockchain because there wasn't enough throughput. But now with these layer 2s and even alt layer 1s, we can really handle that scale. And that's exciting, but it's a huge challenge for being able to index the data. People who have these data pipelines to index cross-chain, they can no longer just say, hey, I'm going to start with Ethereum and that'll cover 90% of the use cases. People really need the data across the ecosystem and across all of these L2s and alt L1s if they want to give a full picture of what's happening.
this brings me to, this wonders me what Andrew might find the most challenging chain at Dune or set of use cases, because you guys support many, and I saw your meta monitoring dashboard. So I'm really curious to hear your perspective on that.
Yeah, totally. I'm happy to speak on it, and I think there's two areas of complexity here. I think one is just on like getting the data transformed after it's in, right? Just dealing with reorgs is a lot of work. If you check out the meta monitoring dashboard, I don't know if someone can share a link in the chat for it. But you can see like there's differences for chains. Some of them are 1 minute, some of them are 5 minutes. And then we do a lot of transformations down the line to make the data easier to work with. Some of it's done by us. We do like decoding, for example. So you have Uniswap decoded into swap, and swap events get their own tables, where the community then works together to transform that into a table called DEX trades, which is then, oh, if I want all Uniswap trades across all chains, I would just think of it as DEX trades. And so there's already headache of like, how do people find this data set? How do they understand the latency of like what they're getting? And like, is that latency coming from us? Is it coming from QuickNode? Is it coming from somewhere else? And it's also like when people, by the time they get to Dune, like they're already halfway through their exploration journey. You know, like they probably saw something on DeFi Llama and then like checked out something on like Parsec or Etherscan, and then maybe looked through QuickNode and was like, oh, okay, QuickNode has like these logs. So by the time they get to Dune, their headspace is all like messed up, you know? I think that's honestly one of the bigger problems we deal with than just like, how do we get the data in and transformed? Like I have so many calls every week where I'm just like, okay, calm down. There's like 50 tools. Let me just walk you through like when you need an indexer, when you need an explorer, when you need a query engine, when do you actually need like a data warehouse. It's pretty complex. You know, I think most people who come to the space, they're just like, oh, I thought blockchains were easy to develop on. And it's like, oh yeah, it's easy to deploy. You got a lot of work like cut out for you after you deploy things though.
I see we're starting to get a few votes in for our poll. Just a gentle reminder to pop over to the poll tab and let us know which of the use cases for enhanced blockchain data you're most interested in learning about today. Guys, could you fill us in on maybe some of the sort of benefits and shortcomings of different techniques for getting data out of blockchains?
Oh yeah, absolutely. We just had this amazing presentation in ETH Denver where Carl featured various ways of getting the data out of blockchains and trade-offs. I'll leave some section closer to the end for Carl to cover, you know, the differences between various ways of getting the data out. But it's really a trade-off of several things. How simple it is for you to get the raw data, how easy it is to you then to refine it down the pipeline and reach it, and so on. It's also somewhat use case specific. If you're trying to get the most accurate real-time data, you would probably prefer the least augmentation for your data possible. So you'd stay as primitive as possible, which means probably relying on JSON RPCs or some raw data sets with minimal latency. And this is typical for use cases like trading or DeFi. We see lots of customers directly querying contracts. And although there are alternative solutions in the space like subgraphs that augment this data, there might be some trade-offs when it comes down to latency specifically. Carl, would you add something to it?
Yeah, I think, you know, there's numerous solutions that are out there. You can start off with just the raw RPC, which is going to make it as easy as possible to get the data, right? Or as easy as possible to get started, actually the hardest to get to the data. And then you can use, I think there's another level up where you can start to use things like what companies call enhanced APIs, you know, like an NFT API or a token API, right? Those have their own set of challenges. There's a lot of exceptions that people like Dune have put a lot of work into addressing and finding and resolving. The premium enhanced APIs also have found those and addressed them, but you have to be really careful to make sure that they have coverage. A very simple example of that is something like CryptoKitties or CryptoPunks, right? They were so early that they don't fit the standard NFT on-chain standards, right? So a indexer that's only looking at the exact specifics about the specification won't catch those, right? So people have to put in a lot of time to find all of the exceptions, and I can assure you there are a lot to be able to have a enhanced API that covers things. That being said, it is pretty easy to use and get started, but it's also very rigid, right? The data that you're pulling is going to be exactly what other people are pulling from there. But maybe something like a wallet, it might be very easy for you to leverage. Once you start to want to do some aggregation queries or composability with other data, that's where you run into challenges there. So a simple example might be, hey, I want to know everyone who has both a CryptoPunk and a Bored Ape, and these are NFTs. That is not something that you can do without making a bunch of API calls via enhanced APIs and then doing some calculation on your side and then displaying. So then you have to start to run some solutions that provide a query language like SQL or GraphQL or something along those lines. And that's where you start to get into more advanced solutions like subgraphs or even building in-house custom indexes. And those are very powerful, and we'll talk a little bit later about the contrast between those, but it really depends on if you're trying to provide a unique experience to your users that allows charting or math or something that stands out from competitors.
We're also starting to get the results in from our poll, and as you can see, the runaway winner at the moment is digital identities and verifications. I was wondering if anyone would like to speak to the that particular use case and some of the nuances around data for digital ID and verification.
I think data relevance and accuracy would be the most important data quality aspect when it comes down to digital identities. Because if you don't testify the right action on chain, then it completely undermines the whole purpose of building a workload that involves on-chain data for this verification. One of participants on our speaker list today is Antonio. He's been building a great use case related to both finance and transactional data and privacy. And I'd like to give him some space to talk about that, like what's really important for their use case involving digital identities and financial use case.
Yeah. Thanks, Nick. So just to give you the context, FluidKey is a very young project. We launched at the hackathon of IT Global after EthCC in Paris last summer. That's where things started to roll out. We took the idea that, as I said before, one address is not your identity on chain. Like I usually do the parallel in the very age of or years of internet, people used to have an IP address to identify themselves. Like then DNS came into. Then this idea that IP is what you're online. Like people. It's a joke if you say to someone today, but in the past it used to be like that. And that's exactly what's happening now on chain, that you are used to say, okay, this is my address, this is my ID. So we took the technology of stealth addresses. That's a way to have the user generating an infinite amount of addresses while being able to control them all with the same private key. And through a series of techniques we have doing, basically, FluidKey is able to provide an ENS to a user that every time returns a different address. And all these addresses are self-custodial, so we don't have access to them, but just the user with his private key. This, of course, brings the fact that in this way, basically, a user can have multiple addresses, all connected to the same identity, or the same digital identity, And so things like, okay, I want to prove who I am, but I want to have the same wallet connected to different apps. That's something that we are exploring, all controlled by the same key pair. So the user is one, and but it's not immediate to just looking data on chain to connect those identity. It's close to impossible. Mathematically, it's impossible, that part.
Antonio, what is the volume of addresses we're talking about here? What is the number of addresses you're tracking?
Yeah, so the order is in the orders of dozens of millions. Okay, so just give you an idea. If you have this ENS and you refresh every time you refresh, a new address is generated, and the same one is never returned twice. So millions of addresses. It's easy to generate, because if a user can generate 20, 30 per day. So if you do the math over a year, with just a few thousands of users, you get to millions of addresses. Just a small amount of them receive money in the end, because sometimes, I open the page to send the payment, I just input in the wallet, but then I have to go out and go back again. So tracking in a way that's also cost efficient was like a very big challenge for us.
Yeah, that's for sure. I mean, for you, we don't need to get any lower below the tip of iceberg to see how big of a challenge it is to track the volume of data. And also for chains like, you guys work on Ethereum, but I assume you also use Optimism, or what are the chains you base?
The public one we have now, just a simple testnet and Optimism, but by the end of this month, we will be, and actually run today the test that successfully passed, we will be on Base, Arbitrum, Polygon, Mainnet, and we're also planning Binance and Gnosis.
Yeah, those are very intense chains. Like the number,
especially Arbitrum. Yeah, the amount of blocks they produce per second is pretty intense.
Yeah, for those who listen and explore like different block finality times, Arbitrum prints a block every 200 milliseconds. For comparison, Ethereum does that in 12 seconds. Dune has a great dashboard showing those differences. So yeah, as we can see, those challenges are very different. And as we dig beneath the surface, let's explore some common issues encountered when building with custom indexes or just dealing with data. I'd like to launch a poll for our audience to just reveal together how much of a challenge it is to get the data out. Let's take a quick poll to share our experiences and perspective on how to manage the blockchain data. I'll just stop sharing and we could bring up the poll.
Yep, the poll is live in the polls tab at the moment, and the votes are starting to come in.
Awesome.
Pretty even split at the moment.
Yeah, let's give them some time to go through the options here. Andrew, can you comment on set of challenges you might be facing on Dune's side when dealing with getting the data out? So just extracting the data for all these chains, besides the rework portion we previously mentioned.
Yeah, definitely. I mean, I think the hard part, and Carl already kind of touched on this, is like we're now at a point where deploying a chain is as easy as deploying an ERC20 token, basically. So it's like, all right, it's one thing to scale our pipeline for 20 chains or 30 chains. It's a completely different beast to scale it for, like, I don't know, like there was a post, like Astria did a DevNet of their rollup launches, and they said, they're like, oh, 500 rollups launched in a weekend, so there's like a whole new game around, like, okay, like how do we basically convince QuickNode to index all of these 500 chains, and also the fact that like a lot of these like die off, right? Like we saw like Public Goods Network with Gitcoin. They shut it down after a year or so. And it's like, okay, it's not only is it that we have to try and capture all of these chains, but a lot of this, like between the ones that shut down, between the ones that use different like DA layers, like it's not just oh, we could catch up and get all of these eventually. It's like, oh wait, some of these, like the nodes are going to stop running, or like maybe someone wasn't capturing the DA. Like it just becomes a lot more troublesome to keep up with. And then we hear stuff like I think like ZK Sync has some custom opcodes and whatnot that then get in the way of like how we normally decode things. And what happens when, like, right now we're just experimenting with like, oh, what happens if you store the data somewhere else? But what happens when people start adding completely like custom opcodes? Like who deals with that? Should that just be on QuickNode? Should that be on Dune? I think that is something that definitely keeps us up at night, and is like one of like probably like definitely a bigger pain point than reworks at this point. So
Gotcha. And as we move down the pipeline, I see decoding taking more votes at this moment. How do you guys build that out in Dune so that you can decode essentially the most out of raw blockchain data?
Yeah, I think we're the only provider out there that turns every function and event on a smart contract into a queryable SQL table that's like not written in not in binary. Like anyone who's familiar with crypto data and has looked at Etherscan has seen like, oh, the data is normally in like hex or binary, you know. But we take the ABI that's verified through Etherscan and we say, hey, for all 18 functions and events here, you can query each one individually. You can join it however you want. It makes it much more easy to like find the tables you need, and it makes your queries much faster as well. I think we have over 600,000 contracts decoded on Dune. That applies to factories, that applies to proxies, diamond proxies, like words you probably maybe haven't even heard of yet. That's one of the things we pride ourselves on, is just having probably the largest, not probably, definitely the largest, I think, decoded data set that's like community sourced right now.
Carl, would you like to mention how we're taking the decoding problem forward with the marketplace we have in QuickNode?
Yeah, absolutely. You know, one of the things that I'm sure is a huge challenge in what Dune is working on is, you know, access to a file called an ABI that, you know, most of us might think without digging into actual implementation that this type of information would be publicly available. But unfortunately, when activity happens on a blockchain and you attempt to read it, sometimes you don't even know how to decode it. You know, it's in this kind of abstracted format referred to as hex, and then to decode it into something that is human readable, there's a file referred to as an ABI. And that ABI is only sometimes published and made publicly available. So without that, you don't even necessarily know what might be happening within those contracts. So there's been some movement in the space to try to make those more and more publicly available. Etherscan is probably your best resource right now to be able to get them. But on the QuickNode side, we've actually recently launched a smart contract explorer that I can drop the link to in the chat. Been getting a lot of traffic there, people wanting to be able to view smart contract source code and the ABIs. But what that allows you to do is be able to see something like, hey, a transfer happened of ownership of an asset from one person to another, right? You'd think that would be a very simple thing to identify happening on the blockchain, but unfortunately it's not. So, you know, that's one area in which we're helping people out. We're trying to get them access to these ABIs. I believe we're also going to be working on a API to be able to offer those through there. And we also provide access to a wide range of APIs that have decoded data already available. Ones that are created by QuickNode, such as our NFT and token APIs, but also third-party ones through partners that provide access to additional NFT data and token data. I can also drop the links to that in the chat.
Thank you. Looks like we're getting more votes for data relevance, accuracy, decoding. To some extent, I see lots of people voting for reworks. Looks like we anticipated that, and we have a slide explaining those common issues.
Well, that's lucky. I'll just stop sharing the poll so you can bring up the slides.
Absolutely. So these are the common issues when building with custom indices. And they also apply to some extent, they apply to raw blockchain data sources, such as RPCs. Relevance is mostly affected by delays, but to some extent by reworks. We see that Ethereum is facing reworks quite frequently. On Etherscan, you could track the rate of forks that, by the way, are specific to their own data sources and nodes, right? So everyone in the decentralized network has their own forks happening, but we can see from an Etherscan perspective that it happens relatively frequently on Etherscan. And when it comes down to Polygon, those reworks could go as deep as 80 blocks sometimes. I'm just scrolling down here. The most deep I see is 26. They are also somewhat frequent, but not as frequent as Ethereum. My point I was trying to make here is that data relevance is affected by reworks, by just how far you are from the data source. So regional availability is important. Another aspect is, from QuickNode perspective, I think I can give a comment on that, because I've dealt with figuring out data parity and data relevance, is the fact that some of the improvement proposals and blockchain client upgrades might bring some unanticipated changes. And they could be as simple as schema modification, or sometimes revert internal transactions for traces, completely undermining the legitimacy of your previously indexed data sets. So we see customers coming in and hitting our nodes to get the same data set. And then, as we talked about ABIs, complexity of accessing this verifiable set is becoming another hurdle for customers to go down the pipeline. There was an article published by Nansen on how they deal with getting the data out for their trading and trading data and data insights product. And this largely applies to many use cases out there in Web3 analytics. So at first, you need to extract the raw blockchain data from nodes, and you could employ various things for that. As simple as getting the data through polling RPCs, employing some data copying solutions, or streaming data. Then decoding and enriching data might involve dealing with ABIs, but also could encompass getting data ingested with off-chain data. We can see here that Nansen relies on CoinGecko data that are usually a good source of price-related data points. And then down the line, they allow their customers to slice and dice this data, build dashboards. So yeah, this is a typical pipeline, and Nansen is just doing what many others out there are doing in this field for analytics. That brings me to a question about how do we make sure that less and less customers reinvent this ingestion and decoding and enriching wheel. We in QuickNode came up with the product idea of Streams that I'm going to feature right now on the slides. So Streams is a product that allows you to build reliable blockchain data pipelines that make it easy for you to ingest the data in a very simple and reliable way. We built this platform with exactly once guaranteed delivery principle. And to demonstrate this in action and make it simpler to understand, just here we have this illustration showing that Streams is this hub connecting essential data sets with your destinations. But to see Streams in action would be also helpful, because here we have Streams running in QuickNode and currently delivering blocks from Blast mainnet to managed SQL instance on Postgres. So as we can see here, blocks are flowing in nicely. And this is the whole purpose of Streams, being this reliable foundation for developers to get the data out. They, of course, can employ other solutions, just as RPCs. And we could talk about those trade-offs in a moment. We have a section related to that in our webinar. I'd like to give the word to Carl to talk about what else is coming in QuickNode on top of Streams. What are we anticipating is going to be the next big thing built on this foundational layer?
Yeah, this is a great question. Can you go back to the previous slide here? The one where you had the Nansen, or wherever you had the Nansen diagram. Sorry. Yeah, so this is a great view on the data pipeline that a lot of people follow. You know, I'm sure Dune probably follows something relatively similar. And, you know, what's key here is that it's not just about extracting the data. Extracting the data is very painful, right? People run into issues in being able to pull out every single transaction that has ever happened on the blockchain via API. That's hundreds of millions, if not billions of API calls. Trying to do that within rate limits, hitting errors, retries, reorgs, etc. It's a nightmare, promise me. So what we've provided there is streams to just push the data to you, address all those problems. But then you need to also decode the data or enrich it with additional data, right? And how are you going to do that? Well, you could run those pipelines internally and have to manage that infrastructure. Or we're now launching another product known as Functions, which allows you to be able to process that data on the edge in the cloud right within our infrastructure. Right. So what that allows you to do is be able to say, hey, I don't want to spend all of the latency or the processing internally. I want that to happen right at the edge in QuickNode's infrastructure, right where the stream is coming from, and then deliver it to my system. Further, you don't even have to deliver it directly to your system. Let's imagine you want to take the data and you want to serve it to users of a mobile app. Well, you could take that function and you could filter down to only the data that you want and send that to some type of, push notification service like Firebase or something along those lines, right? You don't even need to then run any backend infrastructure on your side to be able to service that use case to your users. So it allows you to kind of take a lot of infrastructure and processing that you would have to do within your side and completely outsource that to our infrastructure.
Yeah, I'm really excited to shift our launch focus from streams to functions really soon. We'll talk about functions in a moment. The reason I brought this up is those use cases revolving around getting the data out, they are typically structured as ETL or ELT pipelines, or extract, load, and transform, or transform and load. And those two things, load and transform, are usually swapped places depending on the use case. Some customers, they love, and their use case is really centered around getting the whole data set as is into their data lake or warehouse, just so that they could slice and dice it in however ways they want. They have multiple workloads centered around getting this data out, making sure they're up to standard. But for others, like Antonio here, and I can speculate, but for the vast majority of customers out there, just transforming this data and enriching them might be more valuable than getting the whole data set. Antonio, can you comment on that? Is this a good suspicion?
Yeah, no, 100%. No, because of course, when you deal with the ETL, you can do basically anything when you are in the IT space. The problem that comes are also cost, not just in terms of infrastructure, but also in terms of time that you need to spend to build a resilient ETL pipeline or whatever that's connected to it. And when, again, it comes to a startup like we are, making that with an eye on the cost, that's a key feature, if you want to succeed in what you're doing, and you want to be just a great indexer with no value on your core product, because at the end, our core product is not like indexing data, is offering privacy by default on EVM chains. So having the ability to just narrow down to the exact amount of data that we'll need to ingest, that will on one side reduce our ingesting cost. On the other side, will make sure that we don't have even to take care of this infrastructure for the transformation part and loading part of the data. We're just receiving specific data, because in the end now we are focused on transfer that can be either internal transfer, so native asset sent through smart contracts, or token transfer. So that's all the, for example, the call data input of a transaction that adds up to, for a test I did before, close to 70% of the JSON extracted on Arbitrum. That was all this information are useless for us, because we don't need to go through all the call data and run an index on what exactly was done through that transaction specifically.
Makes sense. And for someone like Dune, I think this data is crucial. In their use case, having the data loaded before slicing and dicing and transforming it down the pipeline, as we heard from Andrew, is super valuable, because Dune's use case is also a two-sided marketplace where they have a community of collaborators building insights out of all sorts of data. So yeah, the architecture is really dependent on use case. And we see that there's some prevalence in building sort of use case towards building an ETL pipeline, which is just transforming the data, filtering it, and only then loading in their destination. Helps them make the data actionable in their app. We build out a few samples and boilerplates that help our users to digest various ways of dealing with data, like streams. Hold on, I'm just going to pull this up on my screen here. We have this guide featuring how to get the data from streams and build a simple blockchain explorer here. Carl, you asked me to pull this up on the screen. Can you help me feature this
Yeah,
one?
Absolutely. I think it's just really exciting to be able to give somebody a way to visualize this, right? Because it's really abstract to start talking about all of the things that we're discussing today on the call. It's like, oh, hey, you're talking about hundreds of millions of billions of API calls. Like, the human brain isn't good at visualizing this, right? And what a challenge that would be. So what we've done is we've provided a really simple React app for you to be able to set this up and just stream it to a UI, be able to filter down the data, etc. So, I'll drop the link in the chat here for anyone who's looking to play around with it. Anyone who might be maybe interested in a data analysis as a career, right? Seeing some people in the chat talk about that. This is a good tool that might let you be able to play around with it a bit.
Thank you, Carl. And speaking of visualizing, since we were talking about functions, I'll give functions a quick demo. We have this landing page that tells about the product, and you could apply for early access. But simply enough, functions is just a lambda that helps you make the code reactive, filter it, slice and dice, or enrich it with however data you want. In this particular example we're showing here, we are getting latest blocks with receipts out of Ethereum mainnet, and those are essential data sets that keep track of transactions finalized and also smart contracts events emitted by all these transactions in the finalized block. So what we're doing here was just filtering out all NFT transfers, and then to get some metadata on specific NFTs that were transferred between users, we're calling QuickNode RPCs right in here with our enriched APIs. And what the end it would output to the destination is the JSON payload telling the count of transfers, what was the block number, and all the metadata here. So with products like that and their alternatives, we'll talk about that in a moment. I'll give the floor to Carl to talk about all different ways to filter the data and make those ETL steps. Yeah, so functions is just one way, and it's very robust. It supports 6 languages, very ubiquitous ones: Node.js, Swift, PHP, Ruby. You could upload your Docker container, Python for sure, Go. So that's a multi-language solution for you to make the code actionable, enrich the data, filter it, and make any logic, and practically host your backend within QuickNode. So yeah, I hope this is visual enough. Let's get back to the narrative behind multiple solutions. We saw how streams work. I'll just quickly go through this slide that explains that using streams is as simple as configuring your streams by picking the range of data, then connecting the destination and consuming the data you need. Which we saw in this example with Blast mainnet right here. So we configured that to Postgres. And here I'll just quickly show you the wizard. So you pick a chain, you pick a data set, you pick the range of data you'd like to consume, then we deal with reworks. You could pick a delay or choose an option to get reworks restreamed. And then you pick one of supported destinations, with functions being one of the options, or flat files on AWS. So yeah, this is how we design streams to help you get this reliable foundational layer, which is extracting data and then build on top of it. But we have this comparison for different blockchain data solutions. And Antonio, Carl, Stephen, I'm pretty sure that everyone here has their perspective after having dealt with blockchain data to some extent. Carl had an ETH Denver talk featuring those differences and trade-offs, and I'd like to give him a floor to talk about differences in costs, complexity for various ways of getting the data out.
Yeah, I'll be quite honest with you. Actually, Andrew had done a talk previously that really inspired some of my thinking here. So definitely a shout out to him. The subgraph conversation that he had in a previous talk that he did was really good, where he broke down some of the challenges that you face there. Ultimately, subgraphs are very powerful. I like them as a solution for some of the standard data sets that you might be looking for. Misari provides a good number of off-the-shelf subgraphs that you can see on the graph. I can share a link to that. But once you try to have some composability of cross data set queries, while the graph or other subgraph solutions do allow you to do it, it's very challenging. Especially if you want to bring in additional data that you have from your side, it becomes kind of a bit of a black box. And if you run into any issue during your indexing, usually you're going to have to re-index from scratch. And that's something where you're looking at days, which becomes a pretty serious problem. But if you're taking the data and you're loading it into your data warehouse, then usually if you detected an issue, you're able to identify what it is and solve only that small piece, right? We're talking about changing it from, hey, your customers are seeing a bug for days/weeks to, maybe minutes to hours once you've detected the issue. That is a huge difference for your end users. And that's something that we've, hoped to address here. And then with streams, what we've also done is we have significantly faster throughput than other types of approaches where you might be trying to hit it over API, which also kind of gives you some cost benefit as well when you think about the processing and using functions to be able to filter that data down, or maybe do additional queries still at the edge without the latency in between the calls. So that timing difference makes a big impact on your business, and being able to do it all maybe without having to run extra infrastructure on your side or hire extra engineers to build that, or be able to take those engineers that were building that and put them on something that is a big differentiator for you as as someone who's trying to have a successful product in the market. That effort of pulling the data off and doing the initial decoding, that is not something that's going to differentiate you as a business, right? You building that is really time and money spent on something that could be you bringing something new and revolutionary to market. So yeah, it's kind of some initial thinking. I want to pass it to Andrew because I know he has some good thoughts on subgraphs and whatnot.
Yeah, I mean, I think you bring up some good points. I think something I see a lot, and it's kind of painful, is like I'll see a company want to build a really cool product, and they'll spend 4 months on the data engineering because they're like, oh, I got this working on Sepolia on Ethereum, and this is good. And then they're ready to deploy, and they go to like Optimism, and they're like, okay, I can't do this like batch processing. I need it to be streaming. And then they're like, oh, I want to add another L2. Oh, okay, this is painful. And I see a lot of teams be like, oh, I think this is manageable, because like when you do it piece by piece, it feels manageable, of like, oh yeah, I can add another RPC, or like I can add another ABI. And then like 4 months later, like 2 engineers have a headache, and they're just like, can we please have a better solution for this? Like you have like a half built subgraph, like a few Dune queries, like 5 RPCs from QuickNode. It's overall pretty painful. So, I mean, we're here to help, and we're all building better data products for making the journey easier kind of across the whole lifeline. So, and if anyone ever needs help kind of being like, hey, I don't know how to combine these tools, I'm sure Carl, I'm sure me, we're all open to chatting about it and kind of like helping you speed along your data journey. Because yeah, as Carl said, like you really should be spending more time actually building your product. So
yeah, you brought up a very important point in prototyping speed, or like time to market. We also saw this happening so frequently. Antonio, what's your perspective before trying streams? I know you've tried streams and functions recently. How would you compare the time to actually get the data and start building it and focus on your product versus dealing with alternatives? And what are those in your experience?
Yeah, like even before joining like the adventure, like starting the adventure of FluidKey, it was like back 4 years ago. I tried to run an ETL by myself, extracting all the data from Ethereum and creating a data warehouse where I was running some queries. And I think that was a good time where I learned how difficult that task was. And that was just on L1 mainnet. So then if you go with I was saying before, you want to integrate an L2, whatever, it's going to be close to impossible for a small team. And you need to build a really big team around this task to make it resilient. The good part of Stream is that you don't the next step might be, okay, I don't want to run my node. I can use the node of someone else and query for data. But even that, you have to set up a pipeline where a fetch can fail, data cannot be accurate. There might be a reorg, and you have to handle that. The advantage of Stream is that you literally have just one endpoint, and data flows in, and the accuracy of the data, the timing of the data, all this part is left outside, and that's a big portion of the engineering when you work on these processes. On top of that, if you can even filter with function, you even solve another big problem right after this data comes into your infrastructure. So this part is actually where I see a big advantage. When I play with them, honestly with Fluky, we were looking around now, try to see what was the best efficient also solution to not waste a lot of time on this task. And again, when I tried Streams, I can say that I see the future, because there was a lot of time saving on our side, honestly.
Awesome. I'd like to run a quick check of our audience and launch a poll on how they perceive different blockchain solutions. What are the trade-offs they find matter most to them? Because besides engineering complexity, time to market, of course, there are other various ways to pick one way or another to get the data out. Stephen, are we pulling up the poll?
That poll is live in the polls tab now. Just
Awesome.
watching them come in. When we have a few more votes, I'll bring it up on the screen.
Yeah. So
also, just a quick
option.
note, by the way, if
Yeah.
you have any questions, please feel free to share them in the chat. We'll be taking Q&As shortly.
So as you can see on the poll, we have multiple options here to pick a primary decision criteria when figuring out what's the right way to get the data. Integration and ease of use is somewhat tangential to time to market. Cost effectiveness is another angle to look at it. And although some products might be priced at a premium compared to others, we saw that reinventing the ingestion wheel and actually having a fleet of engineers sitting on top of the ingestion infrastructure ends up being more expensive in the long run, especially when you're in the product building or ideation to release phase. Carl, what's your perspective on that? I know you've talked to a lot of builders in ETH Denver. How would you comment on that?
Yeah. On that previous slide, I know during the poll we can't have that up on the screen, but on the left hand, on the y-axis said total costs, right? It's easy to look at that and say, oh, well, my total cost is the cost for using whatever service does it for me. But what you really have to look at is a term known as total cost of ownership, or TCO, and that's everything that it takes to get something live and maintain it. Right. So that is your dev time. That is your infrastructure costs, meaning the bandwidth that you're paying for, or the servers, or whatever it might be. Right. And the maintenance once it's gone live, as well as any third-party services that you're leveraging. That with the streams ends up being, or I guess with building a custom index, let's start there, ends up being more expensive because obviously you're hosting the data, right? You've set up a data warehouse within your infrastructure and you're piping it all there. But once you start to look at your flexibility of having that in-house, it starts to really pay dividends. And what we've done with Streams is we've taken it and we've significantly lowered that total cost of ownership. I was talking to a very big exchange whose name I can't mention, but they're building a pipeline of pulling data off the chain, indexing NFTs to be able to serve your information about what NFTs you hold within your wallet. Right? This is a huge problem that even, they're facing. And they said, all right, yeah, we're paying a lot of money to run these indexers and run Lambda functions to be able to process it and then be able to build our index and serve it to customers. And what's exciting for us is that we are taking something that is a cost center for people that they don't want to build, right? And that's, I think, the most elegant thing about functions and streams is that it's really easy as QuickNode for us to look at, hey, how do we move up to the stack and help people? And then we start stepping on some customers' toes sometimes in ideas that we have. And streams and functions is perfect where nobody wants to build this stuff. Nobody has competitive advantage by building this stuff. This is something that everyone needs and that then they can go focus on innovating. And that's really exciting for me, right? That we can solve a problem for people and let them go and, hopefully bring us to the next stage of, crypto adoption.
Thanks for that, Carl. I'm aware that that time is pressing, so if the audience has any questions, please do feel free to share them. In the meantime, guys, could you fill us in on some of the future plans for QuickNode Streams? What's next for you guys?
Yeah, as we talked about functions, of course, it's one of our primarily the most important goal for us is to get functions into hands of our customers. But for streams, we also foresee lots of innovation happening, and we have a public roadmap. In case like listeners today would love to explore this, we're going to support more data sets. We're going to work on additional features that would improve the user experience of getting the data out, such as more sophisticated methods of filtering the data with functions, as we mentioned, but also making sure that you could have unprecedented observability of how you deal with data. One of issues that Antonio mentioned is just making sure that your jobs that are getting data from RPCs aren't failing, and we ensure this with streams. But then having observability into it is another aspect. So we're working on notifications and other services that would help inform our customers that something's wrong with their data job. Andrew, what's coming next for your Dune product? I know that you were working in a tangential way of getting the refined data into hands of users. So what's on the Dune roadmap?
Yeah, definitely. Yeah, thanks. Yeah, I think for us, I think we've already explored a lot of what we can with analytics, and having dashboards is great. But we really want to see is all right, there's all these great Lido staking queries or DEX trades analysis. How do we get that more into the hands of developers instead of it just sitting on dashboards? Because ultimately, if this data doesn't get in front of users and get into applications, it's kind of people are missing the context. Uniswap's app is super simple. It's just a swap, but you could have so much more information there, So we're working a lot on improving our API, improving ways of getting this kind of high definition data out and easier ways. So I'm going to put our docs link here, where you can turn any Dune query into an API endpoint. It's paginated. You can run filters on it. So if you had a query that was summing all DEX trades for all traders, and you just wanted to filter for one trader, you could easily just do that in an API call. You don't have to write any SQL at all. Or if you're a larger team that just wants to work with this in your own warehouse, we also do data share through Snowflake now as well. And there's a 30-day trial period. Try it out, either API or data share. Let me know if you have issues. We're just trying our best to get this kind of closer to developers and closer to applications.
So we have a question from Sahil in the chat here. What if I already have a filter script on my computer? Can I upload that code? Nick, do you want to take that?
Yeah, it's relatively simple. In functions, when you create your new function, you could build this in the code editor, or you could upload it as a zip file or in Docker image for your execution layers. So yeah, the code is completely compatible with any sorts of existing. So functions could be used for just taking your code into it from whatever place you were running it at, whether AWS Lambda or locally, with all sorts of dependencies.
Great stuff. I'm also curious, how can blockchain data be used by organizations of different sizes? Because obviously you're servicing everyone from one-man band outfits to massive corporations. Can you share a little bit about that?
Yeah, so one obvious way to look at it is by picking the range of data for prototyping, and especially when it comes down to dealing with chains like Polygon and Binance Smart Chain that comprise like 8 terabytes of total data size. What we see is just picking a relatively small sample to prototype with is a good strategy for someone just trying to get on chain. And that's what you could do with streams today. But yeah, obviously for enterprises of larger size and the ones that compete for data relevancy, the strategy would be to get to deploy your data infrastructure as close to the data origin. And that's what we let customers do with QuickNode RPCs. We are global. We have full coverage in all regions. But also when you deploy a stream, you could pick a region where you'd love to be serve the data from for minimal latency. Carl, would you add on this? I'll start sharing the final slide to close it with some resources so that our customers and users and listeners today, they have some something to look at after being present in this conversation we had about ETLs and data challenges. But yeah, Carl.
Sorry, what is the question at this point?
The question was for organizations of different sizes.
Oh, yeah.
How can they leverage blockchain data?
Yeah. I honestly think what's really nice about a tool like Streams or even Dune really allows people to get up to speed pretty quickly and prototype very quickly. We had, I think Nick just ran a test of indexing Blast. And obviously it's a new chain, but they have a significant number of transactions happening on that chain right now. And I believe it was done within 7 hours. It was fully indexed and within a local data store, right? So this is something that you can have live very quickly and begin indexing and writing queries against. But if you want to do something really simple of, hey, just getting live with accessing data for something like a wallet, then I really do suggest to first try out an enhanced API. We provide them on our marketplace. There are others that are out there that will just allow you to easily say, hey, give me all the NFTs this address owns, right? And I think that's where you should start, right? I think, you probably want to start on something that's the lowest lift and then find out the challenges yourself, because then when you move up the chain and you see some of the things that people are talking about as, hey, here's the pain points that we solve, you'll actually understand how that relates to you and the challenges that you're going to face in your business.
I think we've got time for one last question from Sahil again, which is, does ZK and account abstraction add extra challenge or processing for blockchain data? Who wants to take that one?
Yeah, since it's talking about account abstraction, that's something that we deal with from day to night. I would say that depends on where you see that. Like from a basic like data on chain, I would say no, because I know it's always the same flow of data. Of course, the challenge enters if then you need to start decoding or organizing data in a way that with the pure ZK, not just ZK for rollups, but pure ZK, you need you cannot do what you were maybe used to do before. Okay, so that might be a challenge that when ZK, full ZK, like Aztec will take more the lead that might comes into the space.
Fantastic. I think that's a good one to wrap up on. So just briefly, thanks very much to all of our panel. Thanks to QuickNode for partnering with us on this. Any final words from the panel?
Yeah, we've covered a lot today, but this is just the beginning. You guys can check the resources, how to dive deeper into streams, future functions, and how can they bring you up to speed on some chains. And we support 17 and counting.
Fantastic. Nick, Carl, Andrew, Antonio, thanks very much for your time. And thank you to our audience.
Thank you.
Thanks, everybody.